Good morning, everyone. I'm here to present my paper titled A Review of Convolutional Neural Networks for Classifying Power Quality Problems using Keras API. Uh, Actually, the current power supply now facing a lot of challenges and problems, among which are the power quality problems. The main causes of these power quality problems are increased utilization of nonlinear loads, capacitor and loads switching, uh, transformer energizing, and what have you. The effect of these power quality problems were the introduction of harmonics, voltage sag, voltage swells, transaction, and what have you. Transients, and what have you. So there is need for a timely power classifications device, and at the same time to mitigate the problems so as to have a steady and stable power supply. Uh, Power quality problems are nothing but any deviation manifested or any problems manifested in voltage, current, or even frequency in the power system is referred to as the power quality problems. Meaning that the ideal situation, we need to have a steady sinusoidal waveform. So if there is any anomaly, any deviation in that power, in that size wave, we refer to that as power quality problems. And the quality can either be bad or good. If if the equipment of the customer operate satisfactorily, then he feels that that power is of good quality. Otherwise, it is bad quality or poor quality. So this work is intended to develop a model using convolutional neural network and to classify power quality problems via or through Keras API. There are classes of power quality problems which are mentioned in the paper and tabulated. The parametric equations of these power quality problems are also highlighted or given in the paper. These parametric equations are mostly used in the MATLAB to synthesize the power quality problem signals so as to make analysis, devise, mitigate, and maybe minimize the effect or the occurrence of these problems. And the what we actually use, or the idea behind using convolutional neural network is 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 because of its importance and popularity. Deep learning is a class of power, is a class of machine learning, and machine learning is a class of is a subset of AI, artificial intelligence. So the deep learning is more or less is more or less automatic. So it is automatic in the sense that it automates its operations. The clear difference, the mere difference between the machine learning and deep learning are in machine learning, there is need for to extract features separately before taking it to classifier. But in deep learning, the extraction technique, selection techniques, and the classification process is being merged in one block. So it's been merged together, it's been done together. That's why it is more or less automatic. And there are ways of how this convolutional neural network operate, because it has some layers, some subtle layers. some certain layers. One, it has convolutional layers, it has fully layers, it has fully connected layers, and of course, it has output and input. It has input and output layers apart from these layers. So once an input is taken, the convolution operation is taking place at the convolution layer. What happened is that there is what is called a weight, a canal, a filter. That filter is more or less 2 by 2 matrix, 3 by 3 matrix, and what have you. Can have 5 by 5 matrix, depending on applications. What happens is that the canal matrix slides over the input matrix and produce a picture map. And that picture map is what you apply the activation function, more or less in convolutional neural. We use ReLU activation function as explained in the paper. That ReLU introduces nonlinearity to the system so that the system will have some nonlinear variables and then move to fully layer. Fully layer is 2 by 2 matrix. There is 2 by 2 strides. I mean, it's a stride we use in 2 by 2 so that we downsize or shrink or downsample the output of the the output picture map, and that what we obtain or that what we obtain at the output of fully layer is called the output of our sequence of this sequence of operation. Uh, Fully layer activation function, convolution layer activation function, and then the fully layer. This sequence of operations is repeated over time so that we have a good and uh, a good feature or discriminative feature or predominant features from the input. And this is going to be flattened and move to the output layer, which is called fully connected layer. And from that, the fully connected layer is nothing but artificial neural network that process the input uh, uh, and give the output. The output, we have a function, activation function at the output, more or less is a softmax activation function or entropy. At times we have tangent, we have so many of them. So what we use here is a softmax, and at the output of softmax, we will give the output of the classification as a tag. It will name it. It will name it as the name of the tag. So having the output will now move to the what to the classifier. The classifier will now be able to classify these problems being identified by the classifier. The classifier has classified the problems and then move to the controller. The controller will be able to mitigate these problems at the point of common coupling, that PCC, through this STATCOM. So in this application, we use fuzzy logic controller to supplement. We use it as a supervisory controller so that we can be able to obtain a very good and refined signals so that this STATCOM can be able to mitigate what is missing or inject what is needed from the network. Then we have many literatures were reviewed to make comparison with our method or approach. And that, if you see it from the table, where 20 of literatures or techniques have been reviewed and compared with our technique. And our technique seems to be the more sound and more automatic than the other ones. The method applied to do this is the method applied is indicated in the paper and is highlighted for, for maybe imitation or what have you. We develop a model, and that model uh, does the classification, and the classification, after developing the model, we take it, CNN model, we take it to Keras platform using Anaconda. From the Anaconda, we now open Jupyter notebook, where you have the Python code, where where you have the Python notebook, where you can be able to write your model and then simulate as your own model. And simulation will give you result, and the result obtained are indicated in the paper and explained vividly for elaboration. The comparison was made with the previous automatic methods, of which the one we have, this CNN Keras model, has a higher percentage or higher classification accuracy. So in a nutshell, this paper is more or less on classification, not the control side. The control side will be conducted in the subsequent work. But this review is limited to the classification, and we have obtained the classification and we have compared it with previous method, in which we have the highest. Our method has the highest classification accuracy. So we use CNN Keras classification or classifier or classification model. And of course, we faced some challenges, and the challenges seem to be generic in the CNN model, and they are highlighted in the paper. Of course, conclusion were drawn, and the further research was recommended that this work we did it offline, and they will recommend that the same process, the same work, the same model can be implemented online. And of course, the large voluminous data can be added to, to make it a little bit bigger than what we have. And that can be simulated or can be simulated on the same online data. And we, based on the CNN architecture or variants, we use dense net variant, of which we have our result as obtained. And we recommend that high resolution net V2 can equally be utilized in this our review, so that we obtain an improved result compared to on. Yes, there is an open, the window is open that the work can be improved at any point in time, in as much as we have a controller that will control the device, the problems being classified by the classifier. So thank you. That has been the Adamu Saidu. I thank you very much once again. And thank you for listening. Thank you for listening. Thank you very much.